Hi, grade 11s. Welcome to the third session of the winter school. We're going to start off by asking a question. How sweet do you like your sugar water? 1 spoon of sugar in your glass of water? Or is it 2 spoons of sugar in your glass of water? Maybe you like 3 spoons of sugar in your glass of water. So whether it's 1 spoon in the glass of water, or whether it's 2 spoons of sugar in your glass of water, or 3 spoons, what is the difference between those 3 glasses of water? Let's focus on looking at the particles. So if you could see the particles, what I would like you to do, and you can do this on your worksheet, is draw what you think the particle distribution will look like in the 3 glasses of water. So if I could see the sugar particles, and I'm going to represent them as a number of circles. Okay, in glass 1, I've drawn 5. In glass 2, I've drawn 10, and in glass 3, I've drawn 15. So coming back to these diagrams, I could say that solution 1 is less concentrated than solution 2 and 3, and solution 2 is more concentrated than solution 1. I could also say that solution 3 is more concentrated than 2, but however I describe them, I know that solution 1 is the least concentrated and solution 3 is the most concentrated. So what do we mean by concentration? So let's have a look. What do we mean by concentration? Okay, now solutions can be when you dissolve a solute such as sugar in a solvent like water, but it could also refer to gases and solids. For example, an alloy could be a solution, the concentration of the one part of the alloy compared to the other. But concentration is the amount of solute dissolved in a given quantity of solvent. There are different ways to express it. We could express it as a molarity, amount of solute per unit volume, or as mass of a solute per unit volume, or parts per million, which is the mass of solute divided by the mass of the solution times a million. Okay, those are the different ways to express concentration. We express it, and you will be using it in terms of molarity. In other words, the amount of substance in moles divided by the unit volume, which is a liter in this case. So we will be focusing on molarity. Now here's something else I did in my lab. I took 29.4 grams of potassium dichromate and I mixed it in a flask. I then made the solution up to 500 milliliters. So I had a certain concentration of potassium dichromate. I then poured it into different measuring cylinders, starting with 10 milliliters, then 25 milliliters, and so on. So I ended up with 6 measuring cylinders. Measuring cylinder A had 100 millimeters, B 75 milliliters, C 50 milliliters, D 60 milliliters, E 25 milliliters, and F 10 milliliters of my original solution. So that is how I poured them out. And I want you to focus on, look at the color of the 6 solutions. Because now I'm going to ask you, which of these is the most concentrated? Okay, now I've drawn the measuring cylinders there with the representation that the number of particles is decreasing from the 100 centimeter cubed to the 10 centimeter cubed measuring cylinder. But the concentrations are the same. What is decreasing is the number of particles in a given volume. And if you just look at the measuring cylinders qualitatively, in terms of the color, you can see that there is no color difference between the 6 measuring cylinders, and that should tell you that the concentrations are the same. So for the activity, I want you to calculate that the number of particles is decreasing and while the concentration is the same. Now let's come back to our sugar solution at the beginning. In the first glass, there was only 1 teaspoon of sugar. In the second, there were 2 teaspoons full of sugar. And in the third, there were 3 teaspoonfuls of sugar. And if I asked you which solution is a dilute solution, which is a concentrated solution, how would you answer that question? So let's come back to our particulate diagrams. If you look at the first diagram, there are very few sugar particles in the same volume of water as there are in glass number 3. So there are fewer particles in 1, so we would say that 1 is the dilute solution and 3 is the concentrated solution. So coming back to my solution of potassium dichromate, there I had the 6 measuring cylinders with 100 all the way down to 10 of the same concentration. I then filled up each measuring cylinder to 100 milliliters. And I want you to notice the colors. So based on that, which would you say is the most concentrated of the solutions? So here I've shown how much water has been added in each of the measuring cylinders. Now I want you to draw what you think the particle distribution would look like in those measuring cylinders. So I asked you to draw what you thought the particle distribution would look like in those 6 measuring cylinders. And here's my diagram for you. In the one where I had only the 10 milliliters, those, if you think back to the previous diagram I drew, those particles are now distributed over a larger volume. Because I've increased the volume of water, the number of particles, which can't change, they must remain the same, gets spread out over more space. Therefore, the very light one is the least concentrated. It is the most dilute. So the particles have a larger volume So what I did in my class was to show this kind of thing, that concentrated has a darker color, dilute has a lighter color. A concentrated solution has a lot of solute dissolved in it, whereas a dilute solution has a little solute diluted in it. And when we add water, what we're doing is we're giving the particles more space. So if you can understand that the number of particles change, but just have can spread out in the greater volume of the solvent that is present, then there's a very simple method for which we can use to calculate dilution. To end this explainer video, I'm going to show you a video from Fuse School, which explains this very simple method for doing dilution. So if you understand that when we do dilutions, the amount of particles, the amount of solute does not change, then this method is easy to use, because now you understand that the amount before is equal to the amount after, but what we are changing is we are changing the volume. Because we're changing the volume, the concentrations will change. So I hope this video will help you see how simple this method is.
In this video, we are going to look at what dilutions are in chemistry, how to calculate them using a very easy equation, and even extending to multiple dilutions, which are called serial dilutions. I am sure you all already know that when you have orange squash and you dilute it, that just means you add water. It is the same in chemistry. Dilution is the process of adding water or another solvent to a solution to decrease the concentration. Exactly the same as your orange squash. You have it strong, or you can add more water and make it weaker. So you just need to remember that to dilute a solution means to add more solvent to a set amount of solute, therefore increasing the total amount of solution and decreasing the concentration. So, why do we dilute things in chemistry? In laboratories, solutions usually come in small concentrated volumes so that they are easy to store. You then need to dilute them to a known lesser concentration to use them, such as for titrations. But dilutions are really important for many other things too, such as for doctors and in microbiology. The good news is that there is a very easy equation to help us calculate dilutions. M1 V1 equals M2 V2. Let's have a look at where it comes from, and then we'll see what it means. Because the moles of the solute stays the same before and after diluting, we can say that moles of solute before dilution equals moles of solute after dilution. And then you should already know that moles of solute equals concentration times volume. We can substitute this in, and we get the concentration multiplied by volume before is equal to the concentration multiplied by volume after, which is what this equation is telling us. M1 V1 equals M2 V2. Could it be any simpler? Let's now have a look at how to use this easy peasy equation. So we have our M1 V1 equals M2 V2 equation. Here, our before values are M1 equals 1, and we don't know V1. Our post-dilution values are M2 equals 0.6 and V2 equals 150 moles. Substituting in these values, we get 1 times V1 equals 0.6 times 150. So V1 equals 90 milliliters. That wasn't too tricky, was it? I told you it was a nice and easy equation. Watch the second part of this video to see how to use this equation for serial dilutions. Serial dilutions are just multiple dilutions and are no harder than the example we have just seen. You just need to remember that M1 V1 equals M2 V2 equation.
So grade 11s, try out this equation to help you calculate the concentration of the different solutions that are diluted. Remember, the one was from 10 milliliters and I added 90 milliliters of water, and the last one was 75. I just added 25 milliliters of water. So see if you can calculate the concentrations of each of the solutions in measuring cylinder B to F.